Hello, everybody. Welcome to Math Lesson 2.3. Today we're going to be talking about which product is greater. Okay, now what we're going to do for today's lesson is we will be able to compare multiplication problems before solving them. So we're going to go over some tricks to understand what's happening in a multiplication problem without having to write out the entire multiplication problem to see which one is greater. All right, so as I mentioned in our last lesson, we were going to be talking about what happens when we are adding zeros onto the end of a product, when we're multiplying numbers that are in the tens or hundreds place, and in our product we have zeros on the end of them. We are going to talk about why that is happening today. Okay, I was using that as a little bit of a shortcut in our last couple lessons just to save us some time in our instruction. But today we're going to go over why that's happening so we can understand that a little bit better when we are looking at multiplication problems that we need to figure out which one is going to be greater without solving the entire thing. All right, so to do that, I'm going to use this chart that you should have in your folder. Also, if you'd like to look at your version, it looks a little bit different than mine, but it has the same words on it. Mine's just typed. All right, so this is our place value chart. We're going to be using this pretty often. Once you get used to it, you won't have to use the actual chart because you'll understand what's happening in your head without using the actual chart. But until we get there, this chart is going to be really handy for that. All right, so what we're going to do is we're going to look at this chart, and I'm going to write down what exactly is going on in each one of these boxes here. And if I can find my pen that I think just rolled off the table. Whoop, found it. All right, so here's my pen. So what we're going to do is I'm going to go over what is happening in each one of these spots. So you'll notice I have each number here, okay, for that's our product, what we're trying to get in each one of these boxes. And I forgot a comma in the 1000. My bad. Pretend it's there. All right, so let's start with the number 1. Okay, to get to the number 1, our multiplication fact we're going to have to use, which is the only multiplication fact that'll get you 1, is 1 times 1, right? Okay, now as we move, starting from the 1 over, every time we jump over to the next column, we are going to be multiplying by a power of 10. So each time there's going to be a new 10 somewhere in my multiplication problem because I'm adding a 10 every time I hop a column. Okay, so this is 1 times 1. To get to this one, to get to 10, I'm going to do, sounds so British, 10 times 1. All right, so now we're at 10 times 1. Okay, let's keep going. Now to get to 100, I would do 10 times 10. All right, so let's just look at what we have so far here. I had 1 times 1 for this first one, okay? Going to my next column, I turned that 1 into a 10. This one is still here, so I did add 110 here. That's a power of 10 that I increased by to get to my next column. Going from 10 times 1 to the next one, I went from 10 times 1 to 10 times 10. Again, there's a new 10 here. I increased by a power of 10 as I was hopping the column, okay? If I keep going here to get to 1,000, I would do 100 times 10. Again, there's another 10 there. I'm increasing by power of 10. Now I'm at 100 instead of just 10 times 10. It's 100 times 10. All right. And as I keep going, I'm going to keep filling these out here. Each time I'm just adding a power of 10. I'm starting to run out of space in my boxes, but that's good enough. So we have 1,000 times 10. Our next one would be 10,000 times 10. And our next one, our biggest one, 1,000,000, would be 100,000 times 10. Okay. Each time you'll see my numbers are getting bigger and bigger. I'm adding a 0 because I'm adding a power of 10 each time I go to the next column. Okay, in my place value chart here. All right. I'm trying to think where I was going to go from there. Oh, I remember. Sorry, I'm losing my mind here. All right, so let's take an example. I know these kind of might look like arbitrary numbers for now, but let's talk about one of these and make sure that the math is right here. Let's try 10,000, okay? So 1,000 times 10, how do you know that's correct? Let's skip count it up, okay? So I'm gonna do 1,000 10 times. I'm not gonna do 10 1,000 times. That would take forever. I'm gonna do 1,000 10 times. So if I start with 1,000, I'm gonna show you on my fingers so you can follow along with me, okay? 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000, 10,000. Okay, so I did 10 times and I got to 10,000. Okay, the same with each one of these. Every time I'm going up by a power of 10, okay, I'm adding a 0 here. You'll notice the zeros are getting bigger. All right, and when I multiply it by 10, I'm getting up to the next biggest number in my place value chart here. All right, so I'm going to draw this out with a number you might be familiar with or more familiar with. Okay, I'm going to put this off to the side. I'm going to use a scratch piece of paper for this. Okay, so let's say we have, let's do the number 5, because you guys should all be familiar with the number 5. Been using that for a long time. So the number 5, just like any other number that you are familiar with, has a secret decimal point that is not always seen. It's there, but it's not always seen. We can call it the invisible decimal point, okay? At the end, the right side, the end of any number you are working with, there's an invisible decimal point right here at the end of it. You can even put a 0. That means there's no other pieces. It's just plain old 5. We don't usually put this part because we don't need this part. It doesn't add any information to our number. It's still 5. This is 5, and just the plain old 5 like this is 5. So we don't usually include this. However, it is always there. And when we're talking about place value, you need to understand that every number has this invisible decimal point after it, okay? So if we have the number 5 and we're increasing it by 10, okay? Multiplying by 10. So if I have the number 5, I'm going to multiply by 10. I'm going to go ahead and count 5 10 times. Here we go. So we've got 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay. Most of you should already know that because that skip counting is pretty typical. We've probably been going over that for many years. But what I'm going to do is I'm going to put this into a little place value chart. So when I have just the number 5, it's in the ones place. Go ahead and draw some lines here. Next would be the tens place. And last would be the hundreds place. Well, not last, there's way more that we could go, but we're not going to get that big today. So I have 5 here, right? When I just multiplied by 10, okay, I counted 10 times with the number 5, I went over to the next place value, okay? This 5 moved to be a 50. That invisible decimal point is still at the end of the 50, okay? But it's at the end of the 50. It's after the entire number, 50, then the decimal point, okay? So I took this 5, I increased it by a power of 10, and when I did that, it moved over to the next place value column because I'm increasing by a power of 10 every time I go over a place value column, okay? Now you notice if we compare the 5 and the 50, the decimal point is in the same place. The decimal point did not move, okay? It's always going to be at the end of the ones column, okay? Right here at the end of the ones column. However, what I did do is I moved my 5 from the ones column to the tens column, okay? The 5 went from here to the tens, and that means I had to fill in a 0 for where my ones used to be, okay? I went from 5 to 50. Now, if I multiplied by 10 again, now this 5 is going to move over again to the next column, okay? And you can work out that math on your own if you don't believe me. Just do it on your hands. 50 times 10, it's going to be 500, okay? Because I'm moving that 5 again over to the next column. I'm multiplying by a power of 10, so it's now from the 50 or from the tens column to the hundreds column. I went from 50 to 500. So now I have 500. And again, that decimal point is staying the same. It's in the same place, okay? Now, parents and maybe even a former teacher that you've had before might have said that the decimal point is moving. Okay, that's actually how I was taught also, was that the decimal point is moving. Okay, but it's really important to understand the decimal point is not actually moving. That's a shortcut trick that some people use, but we want to understand from the very beginning that the decimal point is not moving. What's moving is your main number from place value to place value. Okay, your 5 goes to the next place value, and so there's a new 0 there. Okay, your 50 goes to the new place value, so there's again another new 0 there, but your decimal point is always staying here. Okay, so don't refer to it as moving the decimal point, because the decimal point is staying. All right, what we are doing is increasing by a power of 10. We're going to the next place value. Okay, and that's why there are new zeros each time, but the decimal point does not move. Okay, keep that in mind. If I even did that one more time, let me add our next column. We can keep doing this pretty much as long as we want till we get tired of it. If I go again by another power of 10, I'm just moving from the tens to the hundreds, now to the thousands column. Okay, now I'm in 5,000. Decimal point is the same, in the same place, but now I'm at 5,000. Okay, so I went from 5, multiplied by 10 got 50, multiplied by 10 got 500, multiplied by 10 and got 5,000. Every time I multiply by 10, I am going to the next place value. Okay. All right, so let's try this with one of the problems we were talking about in our last lesson. Okay, there was one that I kind of did a shortcut for just because we didn't have time. We're going to go over that problem now, and we're going to talk about what exactly I was doing in my head. So 60 times 40. All right, 60 times 40. Now, when we are doing 60 times 40, what we're actually doing is I'm going to break this apart a little bit more. 6 times 10, that equals 60. Times 4 times 10, which equals 40, right? Now, okay, so I have 6 times 10, I have 4 times 10. All I did was I just broke these apart into the, what is it called? I'm so sorry, I'm totally blanking. The ones place, goodness gracious. Sorry, friends, my mind is not working today. The ones place digit times the power of 10 to get up to 60. Same thing with here. The ones place times the power of 10, which got me to 40, right? So a lot of people would probably look at this problem. If you got 6 times 10 times 4 times 10, you would say, oh, well, 6 times 10 is easy. 4 times 10 is easy. That's a cinch. I can do that. So 6 times 10 is 60. 4 times 10 is 40. But then you're left with 60 times 40, and I don't know 60 times 40 off the top of my head. So what I do, and this is what I was doing in my head the other day, I am going to look at different parts of this problem and I'm going to pull them out, okay? And this is called the associative property of multiplication. I can multiply in any order. It doesn't matter where the parentheses are. If these are all multiplication, I can multiply in any order. I'm still going to get the same number, okay? It's all multiplication. That's called the associative property. So what I'm going to do is I'm going to look for the fact I do know, a multiplication fact that I'm familiar with because I know my multiplication tables. That would be 6 and 4. Okay, so I'm going to pull those down. Oh no. Okay, markers are starting to get a little old. All right, so I have 6 times 4. I know that that is 24. Okay, so that's easy because that's one I know off the top of my head. I don't even have to think about it. I already know 6 times 4. Okay, so I took care of the 6 and the 4. Right? Now what I have left is a 10 and a 10. So I'm going to bring those down. So there's 1 times 10 and my other times 10. So 24 times 10 times 10. Okay, now what I can do is plug it into my place value chart here, and I'm just going to work on moving the 24 over to whatever place value column it needs to be in. Okay, so let's do, I'll start with 24. Now when I have, sorry guys, this marker is dying on me. One of my favorite colors. When I have 24, I know that my 20, that's in the tens column. My 4 is in the ones column. Okay, so I'm going to start out by having them like that. Okay, and since it's 24, I know there's an invisible decimal point right here at the end here. I'm going to put the 0.0. Okay, it doesn't change the number. It's still 24, right? But that just shows me my decimal point is right here. It's not going to move. Decimal point stays here. Okay, let me keep drawing a little bit more of my place value chart. I know next column would be the hundreds column. And then if I need it, I can add in the thousands, but I'm kind of running out of space. So let's just start with the 24. Okay, so if I have 24, I need to multiply it by 10 and then 10 again. So I'm going to just do 110 first. When I multiply by 10, everything gets moved over to the next place value. My 2 is going to go over to the hundreds. My 4 is going to go over to the tens. The decimal point stays in place. Okay, so that would make my 2 go in the hundreds place. My 4 goes in the tens place, and I need a 0 to fill in my ones. Okay, that decimal point is staying the same. All right, so I just multiplied by 10 to get from 24 to 240. I moved everything over one place value. Okay, now I have to do it again because I have another 10 here to multiply. So it looks like I do need my thousands place. Go ahead and draw that out. Sorry if it's a little squished. I didn't plan this very well. There we go. Should have scooted that over, but it's close enough as long as I can read it. All right, now I have 240 and I have to multiply that by 10. So again, I need to scoot all of these numbers over to the next place value. So my 200 is going to scoot over to the thousands. My 40 is going to scoot over to the hundreds, okay? And then I'm going to have to fill in whatever's left with a 0. So my 240 is going to turn into 2,400, and then 0 in the tens, 0 in the ones, okay? I'm putting those zeros in those blank spaces. And my decimal point does not move, okay? So I did 24 times 10 and then 240 times 10, and I got to 2,400. Okay, now when I do my answer, I don't have to do the 0.0, but if you want to, that's fine. It does not change the number. Okay, so now that we've talked about that a little bit, I'm going to go back to my notes, and I'm going to use what we just did here. I'm just going to kind of summarize it up. Okay, so first thing we did when we were doing that problem was we did 6 times 4, because I already know that fact, and that's 24, right? Now, when I am multiplying by more than just 6 times 4, every time I'm adding a 10 in here, my product is going to be moving over a place value. Okay, so if I'm doing 6 times 40, that's going to be 240, because this means I have to move everything over one place value. Okay, moving it over to the left means I have to put that 0 on the end to show that I moved it over, right? Okay, for example, if I keep going, if I did 6 times 400, okay, well now there's 2 10s that I have to multiply by, so I'm going to have to move my 6 times 4 is 24. I'm going to move that over 2 times, just like what I did in that last problem, that example. So that would be 2,400. I moved it over twice, which is why I have 2 extra zeros here. I moved it over 2 columns in my place value chart. Okay, and if I wanted to draw that out, actually, I should do that. That would be 6 times, I'm going to break apart the 4, or the 400, I'm sorry. 4 times 10 times 10. Okay, 4 times 10 would be 40. 40 times 10 would be 400. Okay, so I just broke the 400 into 4 times 10 times 10. Then what I did is 6 times 4 first, 24, and then I moved it over 1 column and another column, 24, 240, and then 2,400. Okay, I'm picturing my place value chart in my head right now because I can tell when I move it over each time, there's going to be a new 0 because each time I'm moving it over 1 more place value. Okay, now let's see if we did an even bigger problem with those same numbers, like 60 times 400. Okay, we have that problem. Well, now we have 6 times 10. 60 is 6 times 10 times, now 400 is 4 times 10 times 10. All right, so again, I can do 6 times 4 first because I know that, 24, but then look at all these 10s I have to use. 10, 10, and 10. That means I have to move this 24 over 3 times in my place value chart. And if you want to use this, okay, so if you're starting with 24, right, you can put it in your 2 and 4, okay, and then you can scoot it over 3 times if that's helpful for you. Okay, I can picture it in my head, but if you want to use this chart, go for it. Okay, that's what it's there for. You can write out whatever you need to so that you can visualize what's happening with your 24 when you're moving it over 1, 2, 3 times. Okay, 3 times for your place value. Okay, so let's see. Oh, I forgot to write my final answer there. Sorry. 24 times 10, that'd be 240. Times another 10, that would be 2,400. And times another 10 would be 24,000. It's a big number right there. 24,000. Okay, because I took 24 and moved it over 3 times in my place values. Okay, so now that we've done all of that, what does that have to do with comparing products? Well, let me switch markers since mine's dying. And let's talk about that. All right, so let me do a little. There we go. All right, so let's say you have 2 different multiplication problems, okay? In your homework, you're going to have some problems on either side with a compare box in the middle. Okay, so let's do a sample one. 10, let's do 10 times 30, and then a box in the middle, and 40 times 8. Okay, so in this box, you're going to need to either write greater than, less than, or equal to. Greater than, less than, or equal to. Okay, now, without fully solving each one of these or drawing out an area model for each one of these, I can figure out which one's going to be bigger because I understand how my place value is working. Okay, so for example, 10 times 30. Okay, well, I'm going to look at the first number, 1 and 3. 1 times 3 is 3, right? But then I know I have a 10 here and another 10. Okay, each one of those zeros is a 10 that I have to move it over. So I know 1 times 3 is 3, right? But then if I multiply that by 10, 3 times 10, move over, that would be 30. And times another 10, 300. Okay, so that's 300. Now on this one, I have 40 times 8. Okay, well, again, I know 4 times 8. Okay, that's 32. So I know it's going to be 32 something, but then I have to multiply that by 10, right? 32 times 10, going to move over a place value. Now it's 320. Okay, so now I can see, they're close, but 40 times 8 is larger. So we'd say 10 times 30 is less than 40 times 8. Okay, let's try another one. Let's do 50 times 30. Oh, not very even, but it's close enough. and 20 times 40. All right, so if I'm doing these two problems, 50 times 30, 20 times 40, it looks like they could be pretty close because I don't see one number that's way bigger than the others. They're all pretty close to each other. So let's go ahead and let's do 50 times 30 first. Okay, I'm going to do 5 times 3, which I know is 15. Right? Now, I have a 10 and another 10. Right? So 15 moved over 110 is 150, and then times another 10 is going to be 1500. Okay? It looks like I'm just adding zeros here, but what I'm really doing is moving that number over one place value each time I multiply by 10. Okay? I'm adding a 0 when you're not seeing the entire chart, but every time I know in my head I am moving over one place value. Okay? So 1500 would be 50 times 30, and then 20 times 40, start with the 2 times 4, I know that's 8, and then times 10 would be 80, move over the place value, and times another 10 here, that would be 800. Okay, so it looks like 50 times 30 is greater than 20 times 40. 1500 is bigger than 800. Okay, let's do another one. Let's do 7 times 80 and 70 times 8. Okay, now some of you might already know the answer to this. If you do, great, that's awesome. If not, let's work out how this problem is going to work out, I guess. So let's start with this side, 7 times 8. Okay, I know that fact. 7 times 8 is 56. But I have another 10 here, so I'm going to move it over. 56 moved over to the next place would be 560. Okay, now over on this side, I have 70 times 8. 7 times 8, again, I know that's 56. And then I have another 10, so I move it over to the next place value, and that's 560. So it looks like those are equal. 7 times 80 and 70 times 8. Those are equal. All right, let's do a slightly larger problem. Let's do 600 times 30 compared to 400 times 40. All right, so these two problems, these are using slightly bigger numbers. Now I'm into the hundreds with some of my, I forgot the term, numbers I'm going to multiply. I'll find that in a second. So if I have 600 times 30, let's start with that one. Again, I'm going to find the fact that I already know, which would be 6 times 3. I know 6 times 3, that's 18. Got it. Okay. Now I have a lot of place values to move over. I have 1, 2, 3 place values to move it over. Okay. So that means I'm taking 18 from being right here, 1 and 8, and I'm going to move it over 3 times. So the 1's going to go 1, 2, 3 times over. The 1 is going to be here in the 10,000 column. That's a big column. Okay. So 18 times 10, that would be 180, times another 10 would be 1,800, and then times another 10, that is 18,000. That's a big number. Okay, next one, 400 times 40. All right, again, I'm looking for the one I know. 4 times 4, that's 16. Got that one, right? I've got 16. Now, same thing, I'm looking for how many place value columns I need to move over. I have 1, 2, 3 to move over. So 16 times 10 would be 160, times another 10 would be 1,600, and times another 10 would be 16,000. All right, now I can compare them. 18,000, 16,000. Looks like 18,000 is greater than 16,000. Okay? All right, so those are some simpler problems because I was only using numbers that end with a 0. Okay, I was using those simpler ones so that we could just find those zeros and multiply them out, right? However, I was actually doing the entire problem because these are so simple. But this same strategy can help you even when you have more complicated problems. You don't have to solve out the entire thing. You can use some of these tricks that you already know about place value to help you solve it without, or to help you compare at least, without solving the entire problem out, okay? So, for example, let's do a harder one. How about 24 times 43 compared to 51 times 38. Okay, now you might be thinking, oh great, now I have to get out my area model and I have to multiply all these different pieces and add them all up to find one and then do the same thing for the other one. You don't actually, okay? What we're working on here is just figuring out which one is greater. Okay, you don't have to multiply out the entire thing to figure out which one is greater, because you can use some of these tricks, you know, and rounding and estimating, okay, to try and get the close to the real answer without getting the official one, right? But if you're close enough and you can tell that one of these is going to be greater, you can answer the problem without fully solving either side, okay? So let's start with this one, 24 times 43. All right. So let me start with, let's see, well, I know that 24 is 20 times 4, and then 43 is 40 times 3, right? So if I do, let me just do my 20 times 40, okay? 20 times 40. I know 2 times 4, that's 8, okay? 20, that has a 0. 40 has another 0. So that means I have to move this 8 over 2 times. Okay, I'm going to ignore my ones right now because they're not as important as my tens column is. My tens column is much larger, so it's going to make a bigger impact on my final product than the ones column is. Okay, so I'm just focusing on my tens. 20 times 40. 20, well, that has a 10 in it, so it's going to become an 80. And then the 40 has a 10 in it, so that's going to become 800. All right, so I have 800. Again, I'm not worrying about the ones right now. Okay, I'm just trying to get my closest estimate, or I guess it's not an estimate, it would be rounding. Okay, I'm rounding to the closest big number so that I can figure out which one of these is going to be greater without getting the nitty-gritty little details. Okay, let's do the other side. 51 times 38. Okay, again, I'm just going to focus on my tens. 50 times 1, 30 times 8. I'm just going to focus on the 50 and the 30. Well, I know 5 times 3, that's 15. And then 50, that has a 10 in it, 30, that has another 10 in it. So I'm going to have to multiply by 2 tens, moving it over 2 times in my place value column. So 15 times 10, the first 10, would be 150. And then times the other 10 from the 30 would be 1,500. Okay, so without even looking at my ones, because this is, I know 1 times 8, that'd be 8. Over here, 4 times 3, that's 12. Okay, I could include that, but I don't have to, because I already know that the ones column is not going to make a big enough difference to make 800 bigger than 1,500. Okay, 1,500 is way bigger than 800, right? Without even doing those ones, I don't need to worry about those because the tens are so much greater in the 1,500. So I don't have to solve out the whole thing to know that 800 is less than 1,500. Okay, so you're gonna have problems like that. Don't worry about the ones when you're just trying to compare them. Okay, think about your tens, think about what place value they're in, use your place value chart if you need to, and move those numbers over however many times you need to, depending on how many tens you are multiplying by. Okay, if you need to write these out, I did not write this out, but if you need to write out, well, this is 20 times 4, this is 40 times 3, go for it. Okay, if you need to see that 20 and that 40, that's fine. Okay, just you work on those tens, focus on those tens, use your place value chart, move your number over as many times as you need to, depending on how many tens you have in your problem. All right. If you have any questions on our lesson for today, please let me know. I am happy to help and go over any of this if you need to. All right. If not, good luck on your homework, and I will see you at our next live meeting.